So welcome, I'm glad to see so many of you here. I have half an hour to talk about MySQL high availability solutions. This is a talk that I gave before, but I usually give it in 45 minutes to an hour, so I have to condense it a bit. Some of the assumptions that I'll be making is that I assume you know what high availability is in theory, and you know some of the basic what this is all about, so we can really focus on the MySQL side of things. Yes? Unfortunately, my voice is very weak, so if you want to move forward, we still have lots of places.
There are lots of places, like half of the chairs in front are
You don't need to sit in the very back.
We won't call, nobody's going to call on you to answer a question or go up on the board and do a math problem.
So let's
Plus, I
dive
think
into
it's
the
a little
topic.
cooler up here than it is back there. No, because the window is
I sneaked in 2 or 3 slides about general HA concepts and considerations, but then we will cover things like MySQL replication and how it relates to setting up high availability systems. I also will cover some of the commonly used tools and applications in that environment. MySQL by itself, as we will soon learn, doesn't really provide any high availability out of the box, so you need to use third-party applications or other tools to make it highly available. And I'm going to talk about the most common and popular ones here. I'm probably missing some, and if you have any additional experiences or suggestions, just raise your hand and tell me what I'm missing. DRBD heartbeat are 2 things I will be covering explicitly. I'll also talk briefly about MySQL Cluster, but since we had a whole session about this morning, I'm going to go over it pretty quickly. And then I have a compilation of links and brief information about other tools that you should take a look at if you are interested in making a MySQL server more highly available. Most of the talk, or most of the stuff I'm talking about, is focused on Unix, in particular Linux and OpenSolaris as well. So for Windows, you may have to search for other things. So in general, why do you want to use HA and why do you want to set up a cluster? It's because you need redundancy. You need to make sure that if one of the machines goes down, you have another one that takes place and continues the load and operates on the queries that you're firing against it. What you usually do is you have a virtual IP address that you can move around, so the application simply thinks it's still talking to the same machine, but it's just the IP address that has been transparently moved to another machine that has taken over. And it also has to make sure that the applications are being started and stopped properly, that the data is being migrated to the node that is taken over for the failed one. There are 3 terms that are being used in this context. One is failover, which really means there has been a failure in the application or the cluster. It switches over to the active backup machine. Failback means your first machine that has failed is back up again, and then you make the move back to the main machine. This is useful, for example, if your backup system isn't as powerful as the main system, if you have just a 2-node configuration. Another term that is being used in this context is switchover, which means you as the administrator explicitly tell the HA solution to move your application to the other side if you want to make a maintenance of your system, or if you have to perform some kind of backup or repair or upgrade or anything like that. So the system should also be capable of performing this move by a manual intervention, and most of them do. Usually, an HA clustering solution is not suitable to give you more performance. So high availability clustering is different from high performance clustering. There is some similarity, but it's a completely different concept. For high performance clustering, you don't really care if 1 or 2 of the nodes fail. This just reduces your throughput, but you don't use any data. In the HA configuration, there are different requirements. So load balancing, even though it can be achieved by using an HA clustering solution, is usually not the scope, and it's not what I'm going to talk about. And one of the things, switch slides, that you have to consider is where is your application data being stored? If you have a 2-node system, do you have a shared storage system in the background that takes care of storing your data? Does each node have a copy of the data by itself? then you have to make sure that the data on these two separate nodes is being kept in sync somehow. So you have to make sure that it's being replicated or synchronized. If you have a single shared storage system, this again can be a single point of failure. This is what SPOF means. So you have to make sure that your storage system is redundant. And if you buy a very expensive SAN system, they usually have their own ways of making it highly redundant, and you pay for that, of course. If you have a smaller setup, you usually look into having two PCs with their own RAID disk setups, and you do replication of the data between those systems, because external storage adds on the latency that you have of reading and writing your data, which you have to keep in mind. If you replicate and copy data between the two machines, you can either do the synchronous, which means that every change on the one system is automatically and synchronously replicated to the other side, and the application only can continue when both sides have been updated and have an identical copy again. If you can live with possibly losing some of your data that has just recently been committed, you can go with asynchronous replication, which means that you distribute and commit your data and don't really care if it's on the other side of the fence at the same time. So you get better throughput and better interaction, but you may lose some of your recent data in case of a failure. And speaking about asynchronous replication, immediately gives us or leads us to MySQL replication. This is built into the MySQL server, and it's done in two different ways nowadays. What we have is called statement or row-based replication. Statement-based replication is what MySQL used to have since a very long time. Every data modifying statement that is being issued on the master server, be it an insert, an update, or a delete, or a drop, this statement is being taken and copied over to the slave, and the slave simply repeats the same command on the copy of the data that it has. So this is asynchronous. The statement itself is being replicated, and the slave simply repeats the operation that has been performed on the master. And this is in comparison to the row-based replication, where the actual data and the rows that have been changed are being transferred over to a slave, and the slave simply applies the data on its local copy without having to perform the same statements. Asynchronous means that the slaves can lag behind, and depending on how much write load you have on your master, this can become a problem that you have to be aware of, and you should verify from time to time. And there are ways of how you can do that. The master server maintains a so-called binary log file, which is a specially encoded file where all the statements, all the rows are being stored. And the slave connects to the master server and asks it for new updates. So it's a pull replication system. The slave contacts the master, gets the new information, and then replicates it, while the master doesn't push the information down to the slave. That means that the slave can be down for some time. If you want to shut it down for maintenance, if you restart the slave, it will contact the master and will simply start replicating everything that has happened on the master since the last time the replication has succeeded. Again, depending on how much changes have happened on the master, and meanwhile, the slave may take some time before all these changes have been replicated. It's pretty simple to use and set up. Very well-established practices are documented. It's in the manual. There are tools that use this. So MySQL replication is the first thing that you should look into if you are looking into setting up a redundant system. A problem with it is that the replication on the slave is performed single-threaded. So while on the master you can have several parallel connections that perform updates and inserts, all these are being serialized into the binary log, and the slave will perform and process them one after another, not in parallel. Which means that if you have lots of load on the master, your slave might even have to be more performant to keep up with what's happening on the master. So you need to beef your machine with more or faster disks or even faster CPUs to keep up with that. The whole thing is not automated in any way to take care of a failover situation. So the slave replicates from the master, but if the master goes down, you have to manually or find a script that makes the changes to repoint it to another master. I'm coming back to that in a moment. So there's no heart beating or no monitoring, only on a very rudimentary scale. It's just really replicating of data without any high availability functionality. This is a picture of how this looks like in theory. On the left side you have your MySQL master server, your application sends its queries which are being processed, stored locally on the local tables. All changes are written to the binary log, which is then replicated to the slave, which first takes all the changes, stores them locally, and then processes them one after another using the replication for that. And then makes the same modifications to the local data. Interestingly, the slave itself also maintains a binary log, and you can then, in theory, replicate from this slave to yet another slave if you want to. Okay, now we're going to talk about statement-based and row-based replication in detail, what the pros and cons are. So statement-based replication has been around since, as I said, MySQL 3.23. It's pretty solid. The good thing is your log files are pretty small, since the only thing that is being stored in there is the SQL statement, not the actual data, which makes the replication performing much faster, since less data has to cross the wire. And as you see, each individual SQL statement, you can also use the binary log for auditing purposes. If you want to take a look at what the users are doing, what the application is doing with their data, you can just take a look at the binary logs to decide what's going on. And you don't have to have a primary key on your tables, which is a requirement for row-based replication. The problem is that we have some functions that are non-deterministic. For example, UUID, load file. These are things that are performed on the master, but may look differently on the slave. So you have to be aware that some functionality can't be easily replicated, because either by design or because it's a limitation in the client-server replication protocol. There are some functions that do work. The manual has a good overview of which can be used safely with replications and which you should avoid. Okay. So, row-based replication is something that has been introduced recently. I think it started with MySQL 5.0. Or am I wrong? Is it 5.0 or 5.1?
5.1.
My bad. Okay. 5.1 has been around for so long, so it just feels like...
5.0 was 2005.
Yeah. Yep. So, row-based replication, as I said, means the actual rows are being replicated, which means even non-deterministic functions and rows that are being modified by user-defined functions can be replicated. It's just the raw data that is being transferred across. And this is what most other database systems use as well. So the row-based replication is the de facto standard and pretty well known also by administrators that have to work with it. It also requires fewer logs, since the slave doesn't have to perform the actual statement and go through the optimizer and all these stages. It just dumps the data into the rows that have changed. On the downside, this of course means that you generally have to transfer much more data between the master and the slave. It's not just the statement, it's really all the rows that have been affected. Which means your log file increases, which means you have to perform, or you have to create bigger backups to keep them in a safe place. All these things have to be taken into account. And you need to have a primary key. And possible different result sets on bulk inserts. That means that if you insert many rows on your master and you perform a query while the slave is still replicating those rows, it may not return all the rows until it has finished replicating these. So your result set on the slave might be different from what is on the master if the replication is lagging behind. There's one more thing I wanted to mention. One also positive aspect about row-based application is some queries can be quite costly, and the execution and parsing and the creation of the plan might take a long time, but the result set may be very small, but the query itself is very complex to perform. If you use statement replication, the same statement would have to be performed on the slave, so it has to go through the same math to try to find these few rows. In this case, row-based replication is much faster because, well, the work has already been done, it's just transferring the result. This is some of the scenarios and how you can use MySQL replication. A very simple case where you have one master replicating to a slave. It's also possible to have one master and multiple slaves that replicate from it. You can chain them after another. This can be useful, for example, if you have databases in remote locations that are being updated every once in a while. If you have a main branch of a company and satellite branches that need updated databases from time to time. Something that isn't possible yet is having multiple masters replicating on a single slave. For now, a slave only listens to one master and one master only. Yes.
Is it work in progress or is it just...
It's planned. I don't know if it has really been started yet. It's complex because you really have to change a lot of how replication is being designed. With a few caveats, you can do something like the one below here. It's master-master replication, where you have two MySQL Server which both are master and slave of each other. But there's something that you have to keep in mind, and I'll cover master-master replication in the following slide. It's also possible to create a ring where statements or data is being replicated in a ring. And again, there are a few things that you have to keep in mind to make sure that this works properly, but it can be done. All right, master-master replication. This is pretty helpful if you want to make it easy to switch between one server to the other. You just have to make sure that your application talks to the other ones because they are already set up as being slaves from each other. As soon as the other one comes back up again, you can just replicate all the things that have happened on the backup master when it was down. Something that many people think they can do with it is to use such a configuration for load balancing. Hey, great, I have two masters, they replicate to each other. Let's just fire queries against both at the same time. Don't. The thing is, the data is being replicated and the slave still has to perform the same work as the other machine. So you're basically probably increasing the load instead of reducing it. And if one of the machines fails, since the replication is asynchronous, you can't be sure that they are both in the same state. And if one of the machines goes down, you may have lost data in process. So,
and if you have different data on each machine, you don't know which data is right.
Yeah. So that is something to avoid. Even though it is possible, you should always just send your write queries to one of the masters at any given time. If you need that, well, we had talks about how you can shard data earlier today or how to use partitioning. These are more safe technologies on how to can distribute your write load. So, looking at MySQL replication from an HA perspective. What happens if the master fails? Well, your application likely doesn't work anymore because the master is down and it can't connect to it. And the slave simply stops replicating because the master isn't there anymore. What happens if your slave fails? Well, replication just stops. Your master still continues to work, your application is fine, but you don't have up-to-date copy on your slave anymore because it has stopped replicating. So that's not HA in any way. Replication, as I said, is just one component of the whole scenario. You have to do a bit more to make this an HA solution. So what do you do to make this more useful? You combine it with a real HA solution. For example, you use something like Heartbeat, which is pretty popular in the Linux environment. It's basically one of the de facto HA solutions that you would use on Linux. Heartbeat is a system that allows you to monitor your nodes. Nowadays it can be even more than 2 nodes. And as the name implies, it sends a heartbeat between all the machines and they ping each other every once in a while to make sure that they are all alive and happy. And if the heartbeat isn't being replied properly, the cluster assumes that one of the nodes is dead and can then perform configurable activities to make the server switch to another machine. The basic principle is that you have a virtual IP address that is being assigned to the network interface of the machine, and Heartbeat is capable of transferring this IP address to another node and make sure that the application is being shut down or started up appropriately, so the service can continue there. So in the MySQL case, Heartbeat would reconfigure the slave to become the new master. Maybe it has to perform file system checks or mount a file system if it's being combined with something like DRBD. All these tasks are configurable. Heartbeat provides pre-made scripts that make it pretty easy to configure it with MySQL. And using Heartbeat, well, you can use it for load balancing purposes if you want to distribute your read load. For example, if you have two nodes and one is set up as a master, the other one is set up as a slave, you can use the slave to perform read queries in parallel. And you can use it for creating backups. Since you can shut down your slave, you can perform a code backup, bring it up again, it will resynchronize. All these things are possible in this scenario. Failback seems to be tricky. I don't really have any practical experiences with it, I must admit. But once your slave has taken over and has continued in its role as a master, and you now need to switch back to the original master, you have to make sure that the data that has been changed in the meanwhile is properly being transferred back on the original master node. And configure them. If you configure them in a master-master configuration, they already have some kind of information. But depending on how hard the original master crashed, you may have to restore from the backup and then make sure that the replication is back in sync. So these are things that Heartbeat can't perform by itself at the moment. And the proper failover needs to be scripted, yes. And especially for MySQL and Heartbeat, there's a ton of scripts that you can look into. So let's see, I talked a bit about this already. 2 or more nodes, resource monitoring. Oh, fencing is probably something that you should mention. Fencing means making sure that the other machine doesn't come up in an uncontrolled way and messes with my data, because I can't trust it anymore. Some of the outages may be just temporarily and the system might recover, but if you have already performed your failover to your backup system, you don't want the original system coming back up and starting to behave like it's all good again. In such a case, you usually want to make sure that it's under manual control and the failover is being done in a controlled fashion. So what Linux HA does in that case, it's called stun it, shoot the other node in the head. It basically turns off the power of the other machine. And it can do so by using power switches that can be controlled via Ethernet. Linux HA Heartbeat can use different protocols or connections for exchanging heartbeat information. It could either be a simple Ethernet network, it could be a serial line, and there are other ways of doing this. It should definitely be a separate line of communication than the one that you use to exchange the MySQL replication data, for example. You can have time-based rules based on the time of day. A failover can be performed in different ways. For example, if it's during the daytime, you can assume that an administrator is around and is being alarmed. Maybe not all of the steps are being automated because you want to have some more manual control on how it's being performed and want to look on what it's doing before it actually performs the switch. There's a GUI, but I don't really have looked at it. Usually this kind of stuff is being configured in text files, so you need capable administrator of working with this. And low dependencies requirements, sub-second node failure detection. Yes, it's pretty fast, that's good. And I just realized I'm already running close to half an hour. Can it be? No. 5 more minutes, right?
6 minutes, yeah.
Okay. So, let's take a look at how this looks like. So you have your applications talking with a MySQL master here. It's replicating to a slave. It has a virtual IP address, and Heartbeat takes care of making sure that this is all being failed over, and the virtual IP address just moves from here to there. The application, in the ideal, it shouldn't really notice that. Okay, let's continue. DRBD is another tool that you should be aware of when thinking about high availability. DRBD stands for Distributed Replicated Block Device. It's a kernel model for the Linux kernel. I think it's even integrated in the most recent kernels nowadays. Many distributions provide packages for it, so it's pretty easy to get and to install. You can think of it as RAID 1 over the network. So it basically mirrors every change on your local hard disk drive over the network to the separate machine where DRBD is also running. And you can choose if you want to have a synchronous copy, meaning that at every time the disks are identically on a block level. If you can live with some data loss, you can configure it to be semi-asynchronous or completely asynchronous. There are different ways on how to configure it. Since it's performed on a block level layer, you can basically use it for every application and any file system. It sits underneath the file system, so the data that you store on top of it, it doesn't really care about it, it just replicates blocks. That makes it very application agnostic. It also can perform a resync if there has been a downtime, so it also can catch up with all the blocks that have been changed on the primary node during the downtime. It can also mask local I/O errors. This is pretty handy, so if it realizes that the data on the primary goes bad, it can fall back to the network and get the intact copy from the secondary node for the time being. And you will of course be informed that there's a degradation on your primary disk. The default is that they have an active-passive configuration. So the secondary machine, the file system there isn't mounted. It's just a basic operating system with DRBD, and the replication changes the blocks on the disk directly. You can't mount the file system in this situation because file systems usually don't like if the data on the block level underneath is being changed under its feet. The file system would become heavily confused in that case. So the appropriate way to do this is you have to promote the secondary to become a primary, and the replication has to stop, and then the file system will be able to be mounted. And again, Heartbeat provides scripts that perform this task for you. There are some ways on how you can create a dual primary setup, but it requires a cluster file system like GFS or CFS2, in which case the file system is more capable of working with the block level layer and making sure that the changes underneath don't cause any harm. But in general, you would want to use a logging file system like XFS, RiserFS, ext3 on top of the DRBD, because since the replication takes place on the block level layer, if it goes down at any given point in time, the file system on the secondary is not in a consistent state, and when you mount the file system, the first thing it has to do is perform a file system check. drbd.org is the website on where you will find more information about this. I think I talked about most of this. Integrates nicely. MySQL runs on the active node as usual, and on the secondary, the MySQL server isn't even running at this point of time because it wouldn't make sense since the file system isn't there. In case of a failover, you stop the replication, you mount the file system check is being performed, and then you can start your MySQL server on your backup copy and start accessing the data. Because on the master, the data is being stored in a file, and well, as it's on the block level layer, it may not be in a consistent state.
Do you need to stop the replication?
This is the DRBD replication of block data.
Okay.
I'm not talking about MySQL replication, I'm sorry. Okay.
I was not able to, I'm using DRBD HA, but I just tried to get, I used the synchronous, C, and dropped all caches, all buffers, write cache from the HDDs, controller caches. But if I start continuous insert on the master and then unplug the master, I just 4,000 lines of inserts is missing.
Okay.
I have no idea which cache or buffer is causing this.
Interesting. Maybe that's something that we can discuss in the break, because I'm running a bit short of time. Okay, MySQL Cluster was covered this morning. Just some keywords, I'm not going to repeat it right now. Just be aware, it is separate from MySQL Server itself. It realizes the storage using separate processes that talk with a regular MySQL Server. And you can use MySQL Cluster, in fact, without even using MySQL Server as the front end, but we had this in the morning. And I have 2 slides about cluster and another slide. Just to give you an overview, MySQL servers sit in front of the actual cluster, and this part down here automatically takes care of the high availability without the MySQL server even knowing about it. Cluster and replication. Oh yeah, that is an interesting one that I wanted to get on real quickly. That just came up recently on Johan Andersen's blog, who is one of the MySQL Cluster developers. I find it quite an interesting solution for being able to create both a high HA solution in combination with distributing the load. He uses a MySQL cluster above here that accepts all the write statements and then uses MySQL asynchronous replication to replicate the data to slaves that use InnoDB or MyISAM as the storage engine in the backends. So these perform the complex read queries. The master just accepts writes, and it can even accept these by having several MySQL servers that accept write loads. Since MySQL cluster makes sure that the data is being kept in a synchronous way. That's something that you should take a look at. And the link is down at the slides. I will publish the slides so you can read up on this data. Sorry, I'm running a bit out of time here, so I just real quick. MMM. There was just a talk about it earlier today by Walter. So if you have missed it, take a look at the recording. This is a Perl script basically that automates a lot of the work of setting up 2 MySQL servers being masters and slave of each other and making sure that an IP address is being fed over properly. So if you think that heartbeat is too complex for you, look at MMM, it might be a bit easier to grasp. Flipper, it's more a tool that allows you to easily switch between 2 MySQL servers manually. It doesn't have any functionality for automated failover, but it might still come in handy if you're an admin of several MySQL servers that you need to switch. Red Hat Cluster Suite works similarly to Linux Heartbeat, is a commercial but also available as open source solution developed by Red Hat, part of Red Hat Enterprise, and uses similar technologies and also provides scripts to fail over MySQL. Solaris OpenHA cluster is a very specialized solution for Solaris. There's a talk about it in the FrOSCon main track tomorrow, and one of the developers is down at the Sun booth, so you can get a live demo there. That makes it easy. Some more links. Links Linkfast, continual tungsten replicator, we heard about this earlier today. Market is not really an HA solution, but comes in handy to automate some of the things. And with this, I guess we're done. Thank you. And while we're switching slides, we can take some questions. Thanks.